This call is now being recorded.
All right, can you see my screen?
Yes, madam.
Yes, madam.
Okay. So still got another 10 persons to join us. But anyway, let's just start with the lab manual. I hope you still remember where to access your lab manual. Okay, it is in the unit mining. So over here, you can see your lab report, your lab manual. Where to enlarge it? Okay, so the title of experiment, remember to fill in your title. Okay, experiment 3, determinations of the molar mass of a metal. For this experiment, still we are using titration. Okay, it's something kind of similar to experiment 2. Therefore, you need to have your burette, you need to have your pipette, and so on. Okay, so this introduction is for you to read through. Okay, what is the content? So over the introductions here, later you are going to use this part, okay, to fill in your lab report for the part introduction. There is some gaps for you to fill in. So refer to this page. Okay, so in this content for the lesson today, you're going, for the experiment 3 over here, you have 2 titrations method. Okay, so for experiment over here, we have 2 learning objectives. The first one is to standardize the hydrochloric acid. Remember, standardizations, that means we want to confirm. Okay, we want to double confirm what is the concentrations for our solutions to be used, the chemical. So given if I provide you 0.2 molar, is it really 0.2 molar? Then we have to do standardization. Okay, that is the first learning outcome. Okay, and then the second learning outcome for this experiment is to determine the molar mass of an alkaline earth method, which is your group 2 method, by back titrations method. So back titration is another titrations method. Before this experiment 2, you are using the normal titration. So today we are going to see what is the difference between back titration and the normal titration. Okay, so over here also given you a guideline. If you look at the second paragraph over here, the molar mass of M, this is an unknown metal, okay, can be determined by a back titration. So normally your back titrations have 2 stages. The first stage involves the reactions of this unknown metal, okay, with our excess acid with a non-concentrations. That means this HCl, for example, this acid, we know the concentrations, then only we can determine what is the molar mass of our unknown metal. Okay, that is the first stage. The second stage, we want to use this unreacted acids. Remember in the first step, we are using excess acid. So we want to see how many is remains. The remains one we refer as an unreacted acid. Okay, so in the second stage, the unreacted acid is titrated with a standardized base solution. So again, standardized. So we confirm the concentrations of the base. Okay, therefore, in the second stage, we want to determine the amount or the number of mole of your remaining excess reactant. So from there, working backwards, we can know what is the molar mass or the concentrations or the number of mole of our unknown metal. That is working backward, therefore we call it as a back titration. So the rest of the paragraph over here, you can read through for your own and then later on to fill in the blank inside your lab report. So if you look at the apparatus and the reagents over here, we were going to use scissors virtually. Okay, white towel, pipette filler, the one that to take your solutions inside the pipette. Okay, your filter funnel, retort stand, beaker, burette, pipette with 25 milliliters, analytical balance to weight the mass of the metal. Okay, and then we have conical flask, abrasive clothes adalah kain pasir, kertas pasir. Okay, and then we have aluminium oxide as our chemical reagent as well. Okay, so distilled water, phenolphthalein, our indicator to indicate the color changes. We have our HCl, We have our sodium hydroxide and also the unknown metal M. Right. So let's just go into the procedure. So for experiment 3, there is 2 parts. Part A, standardizations of HCl, and then part B is determinations of molar mass of a metal. Okay, so if you want to jot down somewhere in your lab report, part A, standardizations of HCl, our aims is to confirm or to know the concentrations of HCl, okay, our SS reactant. So part A, we are using the normal titrations method. Normal, that means in the burette, we fill in with NaOH. In the conical flask, we fill in with the HCl. So normal, we want to determine the volume of NaOH used. We want to calculate for the concentration. Okay, but for part B, we're starting to use the back titrations. So the procedure, madam, is not going through with you because later on we want to watch the video. So the steps over here also can refer to the video. So part B, determinations of molar mass, you can jot down in your lab report. Part B is the back titration. Okay, you can see some difference over here. We are not straight away filling the burette, but we want to react the HCl with your metal first. So we have 2 conical flasks to make sure you got the average reading. Remember, the more sample you use, you will get a more accurate result. Okay, increasing the accuracy by repeating a few times of your experiment set. And then after that, if you look at number 7, okay, then we are using burettes again. So we fill in the burette with our NaOH, and then we do the titration steps, okay, to get the how many, what is the amount or what is the volume of our NaOH, and what is the concentrations of the HCl, so we can know the mole of unreacted HCl. Okay, so there's the procedures over here. You can go through on your own, and let's just look at the video of how the experiment is actually carried out. You don't confuse with the term back titration. It's actually just step by step, but we want to determine the reactant that we react at first. Kenapa kita panggil back titration? Sebab kita reactkan satu unknown yang kita tak tahu. Okay, tapi melalui back titration ini, kita boleh kira balik, okay, mass ataupun molar mass yang kita nak tentukan untuk unknown metal tersebut. Working backward, that is back titration. Okay, so is still everyone still with me, yeah?
Yes, madam.
Yes, madam.
So madam share a videos over here. Can you listen to the video?
Yes.
Yes, madam.
Yes, madam.
So this is your part A, the normal titration steps. So first step, we want to rinse the burette with the NaOH. So the concentration of NaOH is fixed already, 1.0 molar. Okay, we take a little bit and then we rinse it because we want to fill with the NaOH, so we rinse it first before we fill up. And then step number 2, we fill in the burette with our NaOH. So until any initial burette reading should be fine. Not necessarily 0.00. Any reading can be. Okay, so this is a very important things inside your practical test, and also every experiment that involve burette. Madam rasanya yang ini mungkin akan keluar dalam awak punya practical test. So make sure you understand about how to remove the air bubble. Okay, so the remarks over here, check your air bubbles. And how are we going to remove it? Very simple. So nampak dekat sini yang bulatkan dalam warna kuning sini ada air bubble. Cuma kita tak nampak sebenarnya ini adalah what is it called? Some space in the burette, in the tips of burette. So we have to get rid of this space. Otherwise, it will affect the reading.
You meant the empty space, isn't it?
Yes, the empty space is your air bubble. Mungkin dalam video tak nampak, tapi awak boleh nampak empty space tak? Dekat sini ada satu line. So maksudnya dekat sini adalah ruang kosong. Ruang kosong ini adalah awak punya air bubble. Okay, so to remove it, you simply open the tap fully and let the solution flow out first. So you will see. Okay, air bubble sudah hilang dah. So remember this step very important. Check the air bubble, remove the air bubble. Once the air bubble is gone, then only you will record the initial reading. Kalau yang tadi sudah check initial reading tapi ada air bubble lagi, kita kena keluarkan air bubble, lepas tu record balik awak punya initial reading. Okay, so remember bureau reading we always record in 2 decimal point. So next part we want to check the HCl solution using pipette. So recognize the pipette. Now the one with the tummy over here, it indicate 25 milliliters pipette. Pipette kita ada banyak jenis. Yang ini adalah 25. So rinse it. And then after that, we take the full volume until 25 milliliters. So this is important. Okay. In the conical flask, we only use 25 milliliter. So remember to do your conversion. 25 milliliters equivalent to 0.025 liter. Ramai yang tak tukar unit. Jadi awak punya pengiraan akan jadi salah. Okay. So 25 milliliters of HCl. So this part is your your calibrated mark. Now make sure you check the calibrated marks over here. Sampai sini kita berhenti. Lepas tu transfer dalam conical flask. And then we add phenolphthalein as an indicator. Place a white towel so that you can see the color changes. Okay, so titrate the acid with NaOH solution. Masih ingat lagi tak dekat burette kita isi dengan apa? Anyone?
NaOH.
NaOH, yes. What do we fill in inside the conical flask? HCl, okay. So straight when you're doing the experiment, you let the NaOH flow until one point, you will see a pale pink color. But in the meantime, kita cuci. Part ini pun penting juga. Kenapa kita cuci? Sebab mungkin ada yang awak punya NaOH dia lekat pada awak punya conical flask. Okay, still on the wall of conical flask. That's why we wash it. Okay, but when you do these steps, washing the unreacted solutions at the inner wall of conical flask, you are not affecting the number of mole of the acid. You tambah volume, you tukar dia punya concentration, tapi yang paling penting adalah number of mole dia kekal. Okay, number of mole of the acid remains unchanged. Yang penting adalah number of mole. So until this point, your indicator will show you color changes. And the more pale pink color you can get is the more accurate one. Okay, so over here you can see a pale pink solution. And then check your final reading for the burette, also in 2 decimal point. So if you still remember for your experiment 2, we do 4 set. One is the gross to know awak punya agak-agak volume macam mana. Tapi gross kita tak masukkan dalam average. This one everyone do it very nicely. Okay, so the average reading we only consider set 1, set 2, and also set 3. And don't forget to divide by 3. There's 2 person, you just give me the total. If you just give the total, which is wrong. Okay, we need the average value. Okay, reading yang dekat sini awak jangan ambil sebab ada kesilapan dekat video untuk reading ini. So reading memang madam sudah bagi dalam awak punya template. Guna value yang madam bagi dalam template itu. Okay, so that one is your part A. We want to calculate the concentration. So now we're moving into part B. Before that, part A, any questions over here? Ada soalan untuk part A?
I don't think so as for now.
Okay, yeah. Okay, so kita proceed kepada part B. Okay, pay attention to part B whereby you want to apply the back titrations method. And the aim is to get the molar mass. So first of all, you need to prepare 2 conical flasks. Okay, and then we prepare 25 milliliter of HCl. So when the words come pipette, that means you need to use this pipette apparatus to take your acid solution. Ini ada pensyarah kimia Miss Fatin. Okay. So teknik ini pun agak susah sikit lah. Kalau ada peluang awak kena try dalam lab. Hands on. Okay, so let all the acid fall into your conical flask. Okay, for 2 conical flasks you have to prepare. Then we clean the metal, the unknown metal M. You have to make sure it's shiny lah, otherwise the oxide layer will affect your result. Yang warna hitam-hitam itu adalah awak punya oxide layer. Lepas tu dekat step ini kita kena make sure kita weigh dulu. Okay, tadi kita ada 2 conical flask kan? So jadi awak kena ada 2 strip of metal M. So 1 for each sample and then we take the mass. Mass also madam dah bagi dalam template.
Madam, I almost
Yes.
forgot. For the first procedure, in the lab report stated 0.1 molar. So in our lab report instead is 1.0 molar. So we're going to use the one in the lab report.
Yes,
Am I correct?
follow the value in lab report because there are some mistake inside this video and then we cannot redo it. We are not in the college now. So we can just alter the value inside the lab report only.
So the step is still the same, is it? Am I right?
Yeah, the step is still the same.
Just the value only.
Yeah.
Alright, noted.
Okay, so step number 4, just now we have a long piece of magnesium metal. Now you have to cut it into smaller pieces so it can react easily with the HCl, make the reactions faster. Okay, and then we place it inside the HCl, inside the conical flask. And then slowly your metal M will dissolve. Metal sudah bagi tahu metal itu ialah apa kan. Okay, add 2 drops of phenolphthalein in every step for your titration. So titrate the unreacted HCl with NaOH. Okay, step ini yang penting sebab tadi awak tengok pada step yang ini. Okay, so when bila dia react dengan unknown metal dekat tadi kan, awak nampak metal tu dalam HCl. So actually what happened inside your conical flask, the metal M reacted with your HCl. Remember HCl is in excess. So now metal M completely react already. But the one that remains inside your conical flask is the unreacted HCl. Okay, awak mesti kena faham untuk step ini sebelum awak buat titration. Metal M dengan HCl dia react. Tapi HCl dalam excess. So selepas react, kita nak tahu berapa banyak tinggal lagi dalam conical flask HCl tersebut. So kita kena buat titration. So this is titration. This is back titration. Okay, so we record the initial reading exactly the same. So titrate the unreacted HCl with the NaOH solution. So yang ada pada dalam awak punya conical flask pada state yang ke-8 ini adalah HCl yang baki daripada tadi selepas dia react dengan metal M. So kita nak tengok berapa banyak yang tinggal. So kita react
Madam,
dengan NaOH. Yes?
so basically speaking, the metal is the limiting reactant, am I right?
Yes, correct.
Alright, noted.
So titration is still the same, phenolphthalein, and then you have to indicate the color changes, washing down the extra excess NaOH into the conical flask, and then you get the pale pink color changes. Okay, so for two sample, also repeating the same thing. React with metal M, and then the remaining react with NaOH. So get the volume of your final burette reading inside your table. So this is your part experiment, and then after that we need to do calculation. For this video, you can rewatch it again and then match it back with the procedure inside your lab manual. So now Madam want to guide you how to do your lab report. Okay, so everyone should get ready with your lab report. Okay, you ready?
Yes, madam.
Okay. So over here, this is your front cover page. Normally no problems, everyone did it fine. But for this one, remember to write your title of experiment. Madam paling risau sebab ini memang markah bonus learning outcome, get it from just now. We have to standardize HCl for part 1. Okay, and then for part 2, to determine the molar mass. So you can copy from your lab manual. Then for the part introduction, also the same thing. I don't think Madam have to guide you to fill in. Okay, the answer is everything inside the lab manuals already. Okay, Madam catat kat sini boleh refer kepada lab manual. Okay, it's exactly the same, you just fill in the blanks only. Okay, so this is the part that Madam want to guide you. So for your data and also result, I give you the pre-data already. So for your first part, titrations of standard HCl solution, we are using 1.0 molar. Okay, how about the volume of HCl?
25.
Yes, this 25 milliliter is the one that we fill inside your conical flask. Okay, and then after that, you have your readings in the burette. We have the gross, set 1, set 2, set 3. So Madam give you some times, fill in the column here. And then I want to know what is the average value of the NaOH used. Kira sekarang, isi sekarang. Nanti boleh terus hantar dalam report. So ingat perkiraan pun masih dalam 2 decimal point kalau awak nak catat untuk burette reading. Tak kisah dia initial ke, final ke, volume ke. Kalau isi dalam table memang 2 decimal point. Okay, if anyone have done, you can let me know what is the average volume, yeah?
24.1. 0.
Everyone's agree?
Yes.
Yes.
25.10 milliliter. Don't forget to jot down the unit. Remember what Madam said. For calculations, no unit is like you're going to the toilet. You are not closing the door. Or you are not flushing the water. Yeah. So units must be there. And if you want, also you can write down the unit after conversions. Remember, milliliter into liter, we divide by 1,000. Okay, and then for part 2 over here is a reactions of metal with HCl. So this one is just now you weigh the 4 cm metal M. Okay, so this is the mass recorded. So 0.0438 and also 0.0466 for both sample. And then part 3 for your titrations with the unreacted HCl. After the reactions, you react the unreacted HCl with the NaOH. So the volume also given over here. But in this case, part 3, you don't have to find separate. You don't have to find the average. Sebab nanti kita akan matchkan sampel 1, okay, dengan sampel 1 dekat sini. Lepas tu sampel 2 kita akan match dengan sampel 2 untuk buat pengiraan. So dekat part 3 ini tak perlu average volume. So over here, you got your values 20.40 and also another one, how many? This one 20.40. How about sample 2? What is the volume?
20.2.
20.20. Remember 2 decimal point, 20.40 sample 1, 20.20 sample 2. So now we proceed into the calculations. Everyone's all right?
Yes.
Yes.
Boleh ya?
Yes, madam.
Okay. So calculation for your last lab report, I'm not very happy because why? Madam rasa ramai yang salin jawapan. Mungkin daripada kelas lain, mungkin daripada kawan awak. Tapi benda yang awak salin tak masuk akal. Madam tak nak tunjuk contoh lah, tapi Madam boleh rasa siapa yang salin. Tapi tak tahulah daripada mana awak salin sebab tak ada walking step. Kalau untuk average awak tak tunjuk walking step, tak ada masalah. Tapi macam mana nak dapat number of mole, macam mana nak dapat concentration, tak mungkin tak ada calculation step. Lepas tu pengiraan pun macam tiba-tiba nombor 0.0925 wujud. Tapi kat atas memang tak ada nombor tu. Kat mana dia keluar benda tu? That's something wrong lah when I recognize some of you is copying the answer without knowing what are you copying. Boleh salin, bukan tak boleh. Boleh. Tapi bila salin tu, awak faham tak? Kalau tak faham, kena tanya. And then experiment 2 is quite important because it will relate to your practical test in your week 11 later. Okay, so jawapan memang Madam ada minta buat correction. Ada yang sudah submit, ada yang tak. Tapi itu adalah responsibility awak untuk carikan jawapan ataupun jalan kerja yang betul. Okay, Madam sudah uploadkan jawapan sebagai awak punya rujukan. So please go and understand it. What is the walking step? Sebab dekat sini memang Madam nampak banyak kalau kita refer kepada eksperimen sebelum ni. Kat sini Madam pun sudah tunjuk dah suruh dah dekat sini. Carikan molar mass untuk oxalic acid. Tapi ada juga yang guna oxalic acid tanpa H2O. Maka maksudnya awak tak fokus lah masa Madam jelaskan dekat sini. Tak fokus tak apa, tapi awak boleh tengok balik OneNote dekat sini. Tapi tak ramai yang cari molar mass oxalic acid yang 90. Padahal dia adalah 126. Okay. So please pay attention. Jawapan ada dekat Google Classroom lah kalau awak nak rujuk balik. So please show your calculation steps, yeah? So the first one, balance chemical equation for the reaction between HCl and NaOH. And you will be able to get the mole ratio or the stoichiometry ratio 1:1. So in this case, we want to calculate the mole of NaOH. So molarity, the concentration is already given earlier, which is 1.0. Okay, 1.0 molar. You want to include unit, can, don't want, also doesn't matter. How about the volume? What is this volume for? Untuk part yang pertama kan, part A. Volume berapa yang kita guna untuk NaOH? Kat mana kita nak carikan?
The average.
Ya, jangan lupa part A kita tengok NaOH ke mana, ada NaOH dekat sini. Okay, kita punya average volume of NaOH which you take for set 1, set 2 and also set 3. So we times it, the one in your liter, 0.241. Kalau awak tak nak guna N sama dengan NV, madam faham, awak belajar dalam secondary school, you learn about this one. So please recognize, if you want to use this formula, N equals to NV, this volume must be in liter. If you want to use the formula over here, the 1/1000, this V is in milliliter. Please recognize both of the differences between both of this formula. Dua-dua boleh pakai, tapi awak kena tahu unit apa yang kita nak pakai. Okay, so in this case, I'm choosing to use the one in liter, and it gives you the number of mole 0.0241 mole. Okay, so from your balance equation, 1 mole of NaOH will react with 1 mole of HCl. So this one is 1:1 mole ratio. Therefore, the number of mole of our NaOH is equivalent to the mole of our HCl. So we know now in your part A, the number of mole of HCl equals to 0.0241 mole. So after you get the number of mole, then we can know the standard concentrations of our HCl in part A. So ini adalah kita punya target dalam part A. Kita nak tahu concentration HCl. Okay, lah cuba masukkan awak punya data dalam mencarikan awak punya molarity HCl. So we got number of moles 0.0241. We got the volume, which is equivalent to how many?
0.025 liters.
Yes, 0.025 liter. Sama dengan 25 mililiter dalam awak punya conical flask. Okay, so dekat sini carilah awak punya jawapan. 0.025. So what is the concentrations that we will get for HCl?
0.964.
0.964. Any unit?
M. Molar.
Molar, capital letter. Okay, very good. Or you can use mole per liter. Okay. Semua orang dapat?
Oh, so basically speaking, we can just write the SI unit for it, isn't it?
You can use mole per liter. Can use capital letter M.
Either M or mole by the power of -1.
Yes.
All right, noted.
Okay. So part 2, number of mole of HCl in 25 milliliter of the standard solution. So kat tadi kita sudah standardize. In fact, actually, we are using 1.0 molar of HCl. Tapi bila awak buat standardization, kita nampak sebenarnya dia punya actual HCl concentration equals only 0.964. So dalam pengiraan yang seterusnya, kita akan guna 0.964. Okay, so calculate the mole of HCl. We are using the concentration 0.964 times with the volume 0.025 in liter, and then you will get the similar number of mole. Sebenarnya untuk step yang kedua ni, kalau awak nak pakai stoichiometry, so kita tahu number of mole of NaOH sebenarnya dia sama dengan HCl. So actually it is the same value which we got over here, 0.0241 mole. Okay, cuma nak bagi tahulah macam mana nak apply benda ni. Nak guna stoichiometry untuk dapatkan mole HCl pun okay, tak ada masalah. Okay. So done for number 2. Everyone's alright?
Yes, madam.
Okay. And then for this one, part number 3. Okay, if you still remember part number 3, we react the metal M with your HCl, then we got the remaining HCl solution. Okay, so in this part, we want to calculate what is the number of mole of HCl which is unreacted. Unreacted dekat sini sama dengan remaining. Berapa yang tinggal dekat sini selepas dia react dengan metal M. Okay, so we apply the formula N equals to NV. So we are using the concentrations of NaOH 1.0 molar. Okay, with the 20.40. Yang ini dapat dari mana? Where do you get this from?
Average.
Yes, this is from the average.
Is it the average?
Hold on. Oh, this is from the first sample. No wonder.
Yes. Sebab tadi Madam cakap untuk part 3 ni kita tak payah cari average sebab kita nak match kan sampel 1 dengan sampel 1. So sekarang ini kita nak match kan sampel 1 punya mass of metal dengan sampel 1 punya volume NaOH. So now we are taking this 20.40 to calculate the number of mole of unreacted HCl. Okay, so Madam catat dekat sini Ini pun sudah tulis lah. Okay, ini datang daripada awak punya sample 1. Okay, let's just continue. So calculate the number of mole of NaOH for this sample 1. And you will get 0.0204. Okay, so similarly, since we're only using HCl with NaOH, so remember your balance equation is still the same. So from the balance equation, 1:1 mole ratio, therefore, number of mole of your your NaOH is the same as the number of mole of your HCl. Okay, so over here, Madam jot down a little bit for you. This is the mole of NaOH used. So this much of NaOH will react with this much of HCl. Therefore, this is the HCl that is used in the titration. Okay, yang ini sudah pakai untuk titration. That means the unreacted HCl react with the NaOH. This is the amount used. So now we want to find what is the unreacted HCl. So macam mana nak carikan mole untuk unreacted HCl? Kita patah balik kepada chapter 1. How to find it? Is there any initial mole for HCl?
Yep.
How many is it?
0.0241.
Yeah. Okay, so Madam bulatkan dekat sini Yang kita masukkan dalam conical flask 25 ml. Okay, and then we have the concentration 0.964 molar. This equivalents to 0.0241 mole. So yang ini adalah disediakan. This is provided. So now we only using 0.02040. So macam mana nak dapatkan baki HCl?
Provided minus used?
Yes, provided minus used. So you recall back chapter 1 when we do the limiting reactant, also you apply this concept. The provided now is 0.0241 minus 0.0204. Okay, so you get the mole of unreacted HCl. And let me know about the values you got.
Uh, 0.0037.
Okay, 0.0037, or you want to write 3.7 times 10 to the power of negative 3, also no problem. But don't forget about the unit, mole. All right? So any question for the sample one until this part?
No. As for now,
Okay, so boleh tak awak cuba untuk dapatkan mole of unreacted HCl for this one, for our sample 2. So, madam pakai warna lain. So, madam highlightkan dekat sini. Okay, and then try to match the volume for our sample 2 from our data just now. So, madam highlightkan dalam warna biru. Itu adalah untuk awak punya volume NaOH for your sample 2. So, similar method. Okay, try to calculate for this one. We try to finish earlier, and then the remaining of the time you can do your revision for UPS. Okay? Kalau ada soalan boleh tanya sekarang ya. Is everyone alright?
yes, madam.
Dapat madam bagi jawapan untuk mole of unreacted HCl untuk sampel 2 sama dengan 0.0039. Okay, so untuk part ini awak complete awak sendiri ya. So, madam proceed kepada part yang keempat. Okay. For part 4 over here, we have to calculate the number of mole of the reacted method. So, tadi untuk part 3, kita kirakan untuk unreacted HCl. So, now we want to know from the unreacted HCl, how many actually we have for our metal. Okay, so ini adalah back titration. Dia pening sikit sebab dia kena reverse the process. So let's just look at the sentence over here and we complete together. M is the alkaline earth method. So alkaline earth method is the name for the elements in our group 2. So what is the charge of the ion it can form?
2 positive.
Positive 2, okay, with a positive 2 charge. And the general chemical equations between this metal M with HCl as follow. We have 1 mole of M, 2 mole of HCl, and then when you have from the product, what will it be?
MCl2 plus H2.
Okay, very good. MCl2, because chlorine, Cl has a negative charge, and then M has a positive 2 charge. Okay, and then don't forget, when metal react with acid, we are going to release What are you going to
Hydrogen
remove?
gas.
Hydrogen gas. Okay, so in this case, you need to you have your balance equation. So 1 mole of metal, 2 mole of acid. So how are we going to calculate the reacted method? We want to use the mole of the HCl reacted with the metal. Okay, so look at this equation. We just now we say the mole ratio equals to 1 to 2, right? So 2 mole of HCl will react with 1 mole of your metal M. Therefore, if you use the 3.7 times 10 to the power of negative 3 mole of HCl, ini dapat dari mana? Macam mana nak link kan?
Sample 1 punya.
Sampel 1 yang tadi kita kira untuk part 3 dekat sini. Okay, madam bulatkan. Guna warna lain. Okay, so this one. Your number of mole of unreacted is the one that react with your metal. Boleh faham dah dekat sini? Can you imagine? Kita react HCl. So first that HCl react dengan metal M. So yang remaining HCl or the unreacted HCl will use to titrate with NaOH. Okay, titrated with NaOH. So sebenarnya yang unreacted ini dia sudah react dengan metal M. So yang tinggal binya baru kita this one is reacted with the metal M. So yang tinggal binya baru kita react dengan kita binya NaOH. So let me. So we are using the mole of unreacted HCl to know or to calculate the number of mole of our metal. Is everyone all right?
Okay.
Yes, madam.
So try to fill in the blanks over here. 2 mole of HCl react with 1 mole of metal. So what is the mole of our metal M? We're using the cross multiplications 1/2 times with 3.7 times 10 to the power of negative 3. And it gives you
1.85 times 10 by the power of negative 3.
okay, 10 to the power of negative 3. So this one 1/2 times with 3.7. Okay, you're using cross multiplication. And then part 2, so after you complete the part for sample 2 just now, you will get the value 3.9, 10 to the power of negative 3. So in this case, also we use cross multiplications to get the mole of the reacted metal. Okay, reacted metal. So which is the first part over there. So over here, you will get about 1.95. 10 to
Yes, 1.95.
Okay. So is everyone get the mole of reacted metal M?
Yes, madam.
Jangan confuse antara HCl dengan metal M Yang tadi kita kira ialah unreacted HCl. Yang ini adalah reacted metal M. So now we are focusing on the metal M. Okay, so you get 1.85 for sample 1, 1.95 for sample 2. So now it's our final step. We want to know the molar mass. So from just now, right, you're walking reverse and reverse and reverse. Don't forget your target now is to identify the molar mass for our initial metal M. Right. So in this case, 1.85, the mole of metal M which has reacted, it has the mass of 0.0438. This one is very initial we recording. Dekat sini madam bagi data kan, awal sekali dalam part sini. Okay, this one. So the mole of metal M we obtained already, 1.85 10 to the power negative 3, is the same, okay, as the mass 0.0438. So dekat sini kita boleh dapatlah awak punya molar mass. So if you remember, number of mole equal to mass over molar mass. So in order to find your molar mass divided by number of mole. Okay, so try to calculate and then give the molar mass of metal M in your sample 1.
23.6756 23.68.
Okay, everyone's agree?
Yes.
Yes.
Boleh? 2, 3, 6, 8. Okay, 23.68. That is for your sample 1 metal. Okay, and then for part 2, your sample 2, number of mole just now you obtained, the mole of metal M reacted, it's contained 0.0466. Refer kepada jadual tadi. Table tadi yang sebenarnya sudah bagi 0.0466. Okay. So apply the formulas again using the mass divided by the number of mole and then see what is the molar mass in your sample 2. So part yang madam kosongkan, awak jangan kosongkan ya, awak isi sendiri. Kira sendiri. Tunjukkan working step.
Uh, 23.90.
Okay, very good. 23.90. Okay, so now we got the molar mass from sample 1 and sample 2. So we want to get the average. So you total up both of it and then divide by 2. Okay, and then you will get the molar mass in between. Okay, how many is that? 33.79.
79.
Okay, gram per mole. Gram per mole is the unit for your molar mass. Okay, so the last one over here is number 6 and number 7. Compare the result with the element in the periodic table. So your metal M, you refer to your periodic table, if you still remember. In group 2, we have the element beryllium, magnesium, calcium, and so on. So which one is the closest to 23.8?
Magnesium.
Magnesium. Therefore, actually, this metal is our magnesium, Mg. So kita boleh bandingkan daripada eksperimen yang kita dapat, yang mana satu dia lebih dekat dengan molar mass yang kita ada dalam periodic table. So in experiment, your mass or your data you obtain from your calculation, normally it will be different from the theoretical value. Okay, so magnesium. Okay, magnesium punya molar mass in theory. Molar mass of magnesium in theory we got 24.3 gram per mole. So if you can see over here, you got 23.79 from the data. Okay, so it's slightly less than that. It means there is some errors or some inaccuracy throughout the experiment. So dari sini mungkin soalan boleh tanya, what is the errors happen? What is the precautions that you need to take? So normally the lab report is like this. Boleh buat cadangan. Yang ini adalah awak punya tips lah, nanti dekat level university ke awak nak buat eksperimen. Part discussion awak boleh discuss. Kat part mana awak punya eksperimen ada kesalahan. Macam mana nak betulkan kesalahan tersebut. memasukkan dalam discussion. Okay, but in this case, discussion is also prepared for you. You just need to fill in the blank. Okay. So dekat sini, fill in the blank. I think I leave it to you. It's quite simple. The titration process part A is to determine. Part A nak determine apa? Ke you nak buat sendiri?
Volume of NaOH.
Sorry?
Volume of NaOH. Is it right?
After NaOH, the target, or you can refer to your learning objective for the first one.
Concentration of HCl solution.
Yes, we want to know the concentrations. If we are not using determine, we can use to standardize, okay, the concentrations of HCl. So nanti pakai dalam ayat lah concentration HCl. Mereka banyak simbol square bracket refer to concentration. Okay, so based on the reactions between NaOH HCl, concentration HCl used in the experiment is, siapa ingat lagi?
0.9664 molar mol.
Okay, 0.964 molar. Oh, you're using a unit mole per liter. So with this known concentrations of HCl, molar mass of metal can be determined by
Back
tadi kita
titration.
guna which method? Which method we use for part B?
Back titration.
Back titrations. Well done. Okay, so two stages are involved in back titration. The first step is the reactions of with excess HCl. So reactions between
Metal.
Okay, so in this case, we are filling the metal before we know it is magnesium. So we're using the unknown M. Okay, so in which the concentration is determined in part A. So in our second stage, the unreacted excess HCl is then titrated with the one that filled in burette is
Sodium hydroxide solution.
sodium hydroxide solution. Okay, you can use the formula, no problem. So to determine the mole of HCl reacted with metal N, by subtract the mole of HCl used in part B with the mole of HCl reacted with NaOH. So this is the formula we applying just now. Okay, to know what is the HCl reacted, HCl used in part B minus mole HCl reacted with NaOH. Okay, it's a little bit different from our calculation just now because we're using to find the mole of HCl of the unreacted HCl. So dia punya cara lain sikit, tapi kita guna mole of HCl provided minus the mole of HCl used to get the mole of unreacted HCl. Yang ini terbalik. Dia nak cari HCl reacted, so using this formula. So if you want to find the mole of HCl unreacted, then it's the one that we used just now. So based on the general equations, mole of metal N reacted with HCl can be determined according to
Stoichiometry.
Stoichiometry. So yang kita carikan 1-to-1 ratio, 1-to-2 ratio, that is all we're talking about the stoichiometry. Okay, stoichiometry ratio, or you simply just write stoichiometry, also can. Molar mass of metal M can be determined, it can be calculated based on its mass. So tadi kita kira molar mass equals to mass over, what do you fill in inside? What do you divide it by?
Mole.
Volume.
Mole. Okay, so based on its number of mole with its mass. So the next one, the molar mass of metal M is, this one is kind of like your conclusion, the average mass that you got just now, which is 23 point, which is the average you got just now?
79.
79. So compare the molar mass of another element, and the metal M is the magnesium. So this, as discussed just now, we bring forward into your discussion. So according to table of relative atomic mass, molar mass of Mg, just now madam have already mentioned, is 24.3 gram per mole. So there is some differences in the reading, 23.79 with 24.3. So what is the reason? Or what is the error? Both of it is the error. Any idea?
The metal strip is not pure metal.
Yes, maybe the metal M is not pure. Lagi? Dia ada banyak error dia it can be a lot of errors, a lot of possibility. So maybe the metal M is not pure.
Some of the hydrochloride acid already evaporated to the air.
Evaporated. Not really, because HCl is not evaporative. Maybe you can think about it's not pure is one of it, or maybe because the oxide layer is not completely removed. Nampak kan tadi dekat metal strike dia ada hitam-hitam, itu adalah oxide layer. So maybe the oxide layer is not completely removed. Maybe you can think about the reaction. The reactions maybe is not complete between your HCl and also metal M is not complete. Apa lagi Maybe there is some air bubbles.
Impurities.
Sorry, AJ?
Contain impurities.
Contain impurities. Yes, maybe contain impurities. But you need to mention where. Is it the metal or the HCl or the NaOH? That can be one of the reason. Ada lagi tak cadangan? Kat sini banyak awak pilih dua saja.
Concentration of HCl in the actual is not same as the in the calculated for the 1 mole of HCl.
Okay, maybe the concentration of HCl is not accurate. You can just mention not accurate. Okay, or maybe we can think about the titration. In the titrations process, maybe air bubbles present. You didn't realize, or maybe the titration value is not accurate. Okay, or maybe the meniscus level when you're taking the reading is not accurate. So choose two arrows over here. Pilih dua saja. So yang ini isi sendiri ya. Pilih dua sahaja. Okay. So last column over here, to overcome the errors, the titrations need to carry out at least, normally we would suggest 3 times. Kalau untuk cadangan awak boleh letak several times. Okay. Many times not very practical lah sebab kita ada masa kan untuk practical session. So normally we will suggest 3 to 4 times. 4 times including the gross lah. Okay. So for your conclusion, answering your learning outcome, the first one, the molarity of the standard HCl solution in your calculation. Just now we have 0.964 molar. And then the molar mass using the back titration, using the average molar mass we have, 23.79. Okay. Don't forget about unit lah, gram per mole. Right. So any questions for your lab report? Ada tak soalan?
When should we submit the lab report?
Same. So today is 9 tomorrow, due tomorrow. So normally madam will give you 2 day time. So madam harap lah sebab madam rasa madam bagi awak dead untuk hantar kerja bukan macam hari ini suruh awak buat, hari ini kena hantar. Sampai esok malam tengah hari. So janganlah sampai esok malam pukul 11 message madam, saya line ada problem, sudah tahu line problem, hantarlah awak sikit. Ada dua hari punya masa awak boleh hantar. Okay, and then one more thing is for because MS32 is not here, for your exercise on 7th of September, sebenarnya madam set dekat MOE email, tapi sebelum ni madam dah set, so tak ada delete, so dia ikut draft time, it appear in your personal email. So siapa yang hantar untuk salah satu, madam tak check, tak ada masalah. Either one you hand in is fine. Ada yang hantar dua-dua, tak ada masalah juga. Tapi ada nama juga yang dua-dua personal account tak ada, MOE account pun tak ada. Yang itu madam automatic record as ponteng lah. So salah satu awak hantar, dah hantar, madam sudah tick dah, tak ada masalah. So jadi ingat untuk kerja yang lain, kita hantar dekat yang baru, ikut MOE. Is everyone alright? Dah clear ya? Mungkin ada masa madam lupa, madam terset dalam personal. Sesiapa yang nampak, sesiapa yang realise, let me know. Okay.
So for now on, we're going to use the MOE.
Ya, MOE. Sebab dalam MOE, untuk awak pun sama, storage is unlimited. Isn't it?
Yes.
I haven't realized that.
Dia tak ada limit kan awak punya storage. But personal, madam personal, the last one is already 90% full. So if let's say it's 100% full, that means I cannot see your submissions already. So we have to move to another account. So that account is unlimited, which is under college lah. And hopefully we won't change it anymore until the end of semester 2. Okay. So fix using the MOE one. So is there any questions before I release you for your revisions on today? Don't forget now, for your UPS this afternoon, start at 4. And then you're given half an hour to complete it. 17 questions. You can stand by all the, the values, ataupun yang list yang madam bagi hari itu kan, boleh sediakan. Nah, tengok nota madam rasa untuk half an hour tak cukup untuk awak flip nota. So baik awak sudah study, sudah revise lah. Okay, half an hour's times and 17 questions. I don't think it will be very difficult for all. Maybe some of it is easy, some of it moderate, some of the question is difficult. Campur-campur lah untuk 17 soalan itu. Okay, so all the best to everyone. This is your first UPS test. I hope all of you can do it nicely lah. Okay, read the questions carefully. Okay, so if no questions, madam will release you over here. Ada soalan lagi?
No, madam.
Okay. So